everyone, we're going to graph the greatest integer function. What the greatest integer function means is the greatest integer less than or equal to x. You will see it written in several ways, this way or this way. We're going to find the domain, locate any intercepts, and based on the graph, find the range. So this is the parent one. So if you get the idea of the parent one, the rest of them are very easy. So what I'm going to do is just look at a table of values here. So I'm going to get my domain values. I'll start with 0, and this is your y, or your f of x. So if I plug in 0, 0 is going to map to 0. You just plug in a 0. If I plug in 1, 1 maps to 1. 2 is going to map to 2. All right. So basically, let's look at different values. Let's look at 1/2. So if I look at 1/2, I'm going to do f of 1/2 equals the greatest integer of 1/2 less than or equal to x. So that's going to go to 0 because you have to round down. All right. If I do f of negative, let's just keep doing positive 3/2. That's the greatest integer of 3 less than or equal to x. Since this is 1.5, this rounds down to 1. So when I'm doing my table, if I put in 1/2, that's still going to be to 0. 1 maps to 1, but 3/2 maps to 1 as well. So let's look at this on the first quadrant here. Let me erase this real quick. So if I go to, once I hit 1, we jump to 1. So I can get very close to 1, and I'm going to actually spread this out. So basically you have this. I'm going to let this be 1, this be 2, 3, 4, 5. So what's going on here is all the points less than 1, like 1/2 or 1/4, you round it down to the integer. Remember, integer are just your whole numbers, including negative numbers. So you go there, and you do an open interval. That means 0.999. If I did 0.999, the greatest integer of that is going to equal 0. All right? Now, once we get to 1, though, that maps to 1. So, it maps to 1. But all these fractional pieces in here, like 3/2 here, that's going to stay at 1. Everything stays to 1 until we hit 2. Once we hit 2, that jumps up to 2. Okay, and if you see the pattern here, it's just going to keep going like this. So 3 goes to 3. All right, and then we go to 4 would jump up to 4 and so forth. And that's why this is also known as the step function. It looks like stair steps. Now, let's go and look. I'm going to clean this up a little because it looks kind of messy. Let's look at some negatives. So remember, when you're doing this, you round down. So if I say, let's -2. If I plug in -2, that maps to -2. So here we go, -1, -2. So -2 maps to -2. This is -1, -2. All right. All right. However, -1.5, that's also going to go to -2 because you round down. That means you're rounding down to the left. All right. -0.5, that rounds down to -1, not to 0. So be careful with the negatives. So a good rule of thumb is to do this. You already see the stair steps here. So just continue it here. And that will, you see, like here's your negative 1/2. That maps to negative 1 here. So if you just keep drawing it in this third quadrant, you get this, and it keeps going on and on and on. All right? So I always just do the first quadrant and then just kind of copy the third quadrant down from the first quadrant. All right. Now, the domain is all real numbers because we can put in anything in here. So your domain is just all real numbers. So I'll just put X here, do it that way. You can do it any way you want. Negative infinity to infinity. However, your range is going to be all integers. It's all integers. There's no fractions. All these numbers here have to be integers. Also, you have a y-intercept at 0, 0. However, your x-intercept is going to be written different. It's a little different. So you're going to write your x-intercept is in between 0 can equal 0 to 1. So that's a little different way to write down the x-intercept. But it touches x everywhere between 0 and very close to 1. All right? So that is it. Thank you. Have a nice day. Bye-bye.